In this video, we are going to have a look at a couple of theorems that go along with polynomials. One theorem is called the remainder theorem, and the second theorem is referred to as the factor theorem. So I'm just going to show you how those two theorems work. And we're going to start out with the remainder theorem. So first thing I want is students to be able to interpret some mathematical notation. So if you look at the box up above here, that says remainder theorem, and this is the theorem. It says if f of x is divided by x subtract n, then the remainder is f of n. So what I would normally ask students is interpret that. What does that mean? What does f of n mean? F of n means to take your function f of x, whatever it is, and substitute. So in this case, if this was x subtract 3, let's use some examples here. Suppose this was x minus 3. Well, then, according to what I read here, I should substitute f at 3, and it will tell me the remainder. So if I apply that theorem here, let's have a look. If I'm dividing by x plus 2, according to this, if it was x subtract n, I substituted the opposite sign. So instead of subtract n, I substituted 3. So here I should be substituting x equals negative 2. Let's put that in here to get the remainder. So the remainder, according to the theorem, should be 2. Replace x with negative 2. And let's see what we get. So negative 8 times 2, negative 16. Positive 4 times negative 4, negative 16. Negative 6 and negative 6. That'll give me negative 32, negative 38, and negative 6. I'm getting negative 44. Now you may say, well, really, does that really work? Let's try it doing division. So now that we know how to do synthetic division from our prior video, let's try a synthetic division on this. We're going to go 2, 2, negative 4, 3, and negative 6, and let's see what we get. Now the reason we're allowed to do synthetic division is because it's 1x plus or minus a number. Bring your first digit down, multiply and put a 4. Subtract, I'll get negative 8. Multiply, put your answer there, subtract. 19, 38, negative 6, take away 38 is a negative 44. Remainder, remainder. It works. So that is how the remainder theorem works at its most basic level. If you want to figure out the remainder when you're dividing by some binomial of the form 1x plus or minus a number, all you have to do is substitute the opposite sign of that number in for x. It will spit out the remainder. All right, let's have a look at, just a second. So if I said, what's the remainder when this is divided by x minus 1? So without actually dividing it out, let's figure out the remainder. So we're just going to, like we did before, use the remainder theorem. So the remainder will be, I'm going to substitute this time, x equals 1. Well, that's a nice easy substitution. So it's 3, 1 to the 4th, 1 to the 3rd, 1 squared, plus 1, subtract 5. So this would become 3, take away 1, take away 4, plus 1 minus 5. 3 take away 1 is 2, take away 4 is negative 2, add 1 is negative 1, take away 5 is negative 6. So I won't do it all out, but I could do synthetic division again here to check it if I wanted to, and I would also get the same remainder of negative 6. Okay, so hopefully you see how the theorem works. Now let's put it into practice here and do a few different things with it. All right, here's one common example of this. I give you a polynomial, such as this, and I leave out one of the coefficients. So I put an a in there, and you're going to try and figure out what that a value is based on the clue I give you here. It says that if we divide by x plus 1, the remainder is negative 12. Well, dividing by x plus 1, according to the remainder theorem, tells me if I put in x as negative 1, it should spit out the remainder. So wherever there's an x, if I put negative 1 in for all the x's, Now, not for the letter A. Leave that there. -1 minus 3. Well, according to what this says as the clue, when I substitute -1 for all the x's, I should be getting a remainder of -12. Well, that leaves me with one unknown, so now I've changed the situation into a nice, easy linear equation. And then we're going to solve this now for A. -1 squared, do your exponents first, so -1 squared is 1 times -4, that's -4. A times -1, that's -A. Subtract 3 equals -12. So I got this nice single variable here all by itself. Let's isolate, so -A equals -5, -8, so I'm going to add 8 to the other side. That will give me -4. I don't want -A, I want A. So if I divide both sides by a -1, in order for this to work, that A value must have been 4. That's the only way you would be able to divide it out and get a remainder of -12. Alright, I got one more something like that. This one I pulled right off of an old unit test. This is a really common question that I like to ask students because it forces you to show me that you understand how to solve something from pre-calc 11 and also something you would have done in Nerve 10 called systems of equations. So basically, it's the same as the last one, except there are two unknowns. I haven't told you the p value, or in this case, the k value. However, I gave you 2 clues instead of 1. And according to this, if we substitute, so if you divide by x plus 1, the remainder is 9. Well, that you should interpret to mean substitute x equals -1, and the remainder should be 9. That's going to make an equation. Now the difference being this time, there's going to be 2 unknowns. Hopefully you have enough knowledge of equations. If you have 2 unknowns to solve for them, you need to make 2 equations. You say, well, that's not enough. That clue by itself would not be enough to figure out p and k. However, it did give me a second clue that said if you divide by x subtract 2, then you're going to get 51. That means that if you substitute x equals +2, well then the remainder should be 51. Well, if I use these 2 clues, this one and this one, it should allow me to create 2 equations. And then if I have 2 equations and 2 unknowns, we should be able to solve what's called a system of equations. Let's try it. So if I take the first one, and I'm going to put everywhere there's an x, a -1. So it would be, I'll do it underneath here, -2k, replace x with -1. Now I know this is hard to see, that's cubed. So -1 cubed plus 5 times -1 squared plus 3p times -1 plus 1 should equal the remainder, which in this case I was told, I'll color code it for you here, the remainder was supposed to be 9. Let's clean this up and see what we've got here. -1 cubed is -1. Multiply that by -2, you're going to get 2. Okay. -1 squared is 1 times 5. I'll get plus 5. 3p times -1 is just going to give me subtract 3p plus 1 equals 9. I think what I'll do is keep the variables together, so the 2k subtract 3p, 2k subtract 3p, and then I'll take the number. So I get 5 and 1 is 6, take it to the other side, 9 take away 6 is 3. So there's an example of what's called a linear equation with 2 unknowns. Well, I can't solve that by itself. I need to build another equation. Let's do that here. If I put 2 in for all the x's, so let's do this substitution now. -2, replace x with +2 because we're dividing by x minus 2, cubed, plus 5 times 2 squared, plus 3p times 2, plus 1 should give me the remainder, which they tell us in this case is 51. Let's clean this up and turn it into something like I had over here. 2 cubed is 8 times -2, that's -16. What's missing here? There's a k somewhere. Forgot the k. That'd be -16k. 2 squared is 4 times 5 is 20. 3p times 2, that's 6p. Plus 1 equals 51. So let's see what we've got. Negative 16k plus 6p equals, I've got 21, so I'm going to subtract that from 51. That's going to give me 30. I do notice that the equation I made here the second time in green, all of these are divisible by, at the very least, 2. I'm going to take this whole, just to make the number smaller, I'm going to divide every term on both sides of the equal sign by 2, which you are allowed to do just based on what's called equality. That would change this into the new equation, which would be negative 8k plus 3p equals 15. Now, I'm going to take these two equations, and you would have learned in grade 10 a solution for solving systems called elimination. There's another one called substitution. You can use either one, but this one is set up very nicely for elimination. I'll show you how it would work. Take this equation, write it here, 2k. Again, this is not something new, but it's something maybe you haven't done in a while, but you are expected to know how to do this when you're sitting in pre-calc 12b. So line up the two equations, one over top of each other, with your variables lined up as they are. Now I'm going to put a line under it. As I said, this one is perfect because the variable p already has the same coefficient. Now I just look at it and say, well, what would I do to eliminate? This is why they call it elimination. I want to get rid of those. Well, the operation you should choose is to add then. Go 2k plus negative 8k, negative 6k, negative 3p plus 3p, 0. Those are gone. 3 plus 15, 18. Now, I have got rid of the variable p, and I can solve for k. That'll give me negative 6, divide into each of those. There's one of the unknowns. It must have been a negative 3. Once you have the value for one of them, pick the easier of the two equations. I'll go with that top one. So now I know that 2 times k, right? 2 times k, take away 3p has got to give me 3. So 2 times k, subtract 3p, has to equal 3. That means that negative 6 subtract 3p must be equal to negative 3. Bring your negative 6 to the other side. So that means you're going to add 6 to both sides. That'll give me 3. Divide by a negative 3. Divide by a negative 3. P in that case must have been negative 1. There are the two unknowns that I was looking for. Now, if I look at that, just... that's not what I wanted. I wanted... There. So that's a pretty in-depth question that requires you to have a real good grasp of a few things. Number one, the remainder theorem to get these equations built. And then this part down here is knowing how to solve a system of equations. This I showed you this year. That was new. This is what we would refer to as prerequisite skills. You are expected to know how to solve a system of linear equations if you're a pre-calc 12b student. Now, that doesn't mean you are, as I said, doesn't mean you remember it all perfectly, but it should ring a bell when you see this, and now you should be fine to work through it again if you had to. All right, let's look at something called the factor theorem. The factor theorem is really just a special case of the remainder theorem, and what it says here is that x subtract n is a factor of f of x if and only if f of n equals 0. Now we want you to get to the point where you can read something like this and it doesn't read like a foreign language. And you can kind of decipher and say, okay, I get what they mean. For example, if I said to you, is 3 a factor of 15? All right, just a simple question. Is 3 a factor of 15? Most students would hopefully say, oh yeah, it is. And then I would say, well, how do you know? And the answer is usually, well, because it divides evenly. I'd say, how do you know? They'd say, well, if I did a division by 3, I'd say 3 goes into 15 5 times. I'd put 15 down here, and I wouldn't get a remainder. So if the remainder is 0, that means that this divided evenly into that number. We're going to apply that same thinking that you see here to this situation, because here's what it says. X take away n is a factor of f of x if and only if f of n equals 0. Well, the last theorem, remainder theorem, said if I had some polynomial f of x and I divide it by x and subtract n, and I wanted to get the remainder, I would substitute n, so find f of n, and it would spit out the remainder. Well, all this is saying is that if you do that, remainder theorem per se, and it turns out that the answer works out to be 0, that just means that this polynomial is a factor of this polynomial, because when you did the division out, you wouldn't get a remainder. So I would know that, for example, x minus whatever is a factor of whatever that polynomial is. So for example, let's look at how this will all play out. I'm checking to see, is x take away 1 a factor of this? Well, what I'm going to do is I'm going to check for the remainder. And if the remainder is 0, it's a factor. If the remainder is not 0, then it's not a factor. Well, if I'm dividing by x minus 1, I'm going to substitute x equals 1. That's what the remainder theorem says to do. So 2 times, not negative 1, positive 1 to the 4th power plus 3 times 1 squared minus 5 times 1 plus 7 should spit out the remainder. 1 to the 4th is 1 times 2 is 2. 1 squared is 1 times 3 is 3. 5 times 1 is minus 5 plus 7 equals the remainder. 5 take away 5 is 0. 0 plus 7 is 7. So I'm getting 7 for the remainder. So therefore, to answer their question, is x minus 1 a factor of that? No, it is not, because it doesn't go evenly. I'm getting a remainder. Right? So according to this up here, it can only be a factor of it if you get 0 for a remainder. All right, let's try another one. So is x plus 2 a factor of this one? Well, let's check it. So we're going to put in x equals negative 2 and see what we get for a remainder. Minus 2 cubed plus 3 times minus 2 squared. 4 times minus 2. Take away 12. So this is what the remainder will equal. Negative 8. This will give me 4 times 3. That's 12. Plus 8. Minus 12, so negative 8 plus 8, 0, 12 minus 2, 0. This time, I'm getting that to be 0, which tells me then that in this case, the answer would be yes. That binomial is one of the factors of this polynomial. All right. Well, we're going to take that information and we're going to use it to factor polynomials that in the past we would have stopped and said, oh no, I can't factor that. I don't know what the factors are. We'll start with this first example. So this is going to be kind of our premise of what we're going to do, but I'll show you out here in steps how this is all going to work. Now, it starts out with you having to determine a factor. So we have to, through trial and error, find something that I fill in here, and I want the remainder to turn out to be 0. Now, it's not completely random trial and error, but it is trial and error to some extent. This cubic, so a cubic expression like this can have up to 3 factors. It says here 3 roots or 3 solutions. If it was to the 4th power, you could get 4 factors at max. So this one I know at max has 3 different factors, if it does factor at all. Not every polynomial factors. You start by looking at the last numeric digit, and the only possible numbers that could turn out to be what are called integral factors or integer factors are factors of this number. So I could use always 1, and it could be plus or minus either of them. So it could be plus or minus 1 because that's a factor of 12. Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So unfortunately 12 is a rough number to have because there's all these different possibilities that you'd have to check and see that they work. So we're going to start by trying. Now, one thing I do notice in this one that these are all added. So when they're all added together like this, and I want to put some number in here for x, and I want to get 0 for the remainder. So that can only happen for this to somehow become 0. I can't add up a bunch of numbers and the answer be 0. I'm only going to try negatives in this case. Again, that's not always the case. It's just because of the way this one's laid out. So let's try x equals negative 1 and see what happens. I would get 6 times negative 1 cubed plus 23 times negative 1 squared plus 29 times negative 1 plus 12. Let's see what we get. So negative 1 times 6 is negative 6 plus 23 minus 29 plus 12. That gives me negative 35 and a plus 35. Well, I was lucky. First one I tried worked. It won't always be that way, but in this case it did work out that that first one that we did through trial and error gave us 0. Okay, so what does that mean? Well, if I'm putting in negative 1, you got to put your brain in reverse for a second. That means that I'll use this symbol, these 3 dots, therefore, that means therefore, x plus 1 must have been a factor originally. And the reason I know that is because according to our factor theorem, which I put up above here, if you fill in negative 1, remember, it's always the opposite sign you fill in. So for example, if we had x take away n, we filled in n. Well, I can see that I filled in negative 1 for the x. Therefore, the factor that that would have come out of would have been x plus 1. So what I now know is that x plus 1 is one of the factors. Now think of it this way. If you had a number, let's say 24, and you told me, hey, I know that 4 is one of the factors of 24. Well, here's what I'd say to you if you didn't know what the other one was. Now, I know you do know because it's easy multiplication. But in theory, if you didn't know what the other factor was, all you knew was that 4 went evenly into 24, and I said, oh yeah, how many times? Well, I know you know off the top of your head it's 6, but if you didn't know, you could calculate it. You would take 24, and you would divide by 4. And you'd say, oh, 6 times 24, and you get 0. And then you would know then that these two multiplied together make 24. Well, think of it like this with this polynomial. You have started out with the polynomial, just so I can see it here, 6x to the third plus 23x squared plus 29x plus 12. And what you just figured out is that x plus 1 is one of the factors of it. So looking at your numeric example over here, you have figured out that x plus 1 is one of the factors. What you want to figure out now is what two things multiply together to give you that. You're going to do like you did over here. And this is why you were shown how to do long division and synthetic division. You're going to take the original expression and divide it by what you found to be a factor, and that's going to give you this other factor. I'm going to do it with synthetic division right here. So it's going to be 6, 23, 29, and 12. It's a positive 1. So your 6 comes down. 1 times 6 is 6. 17, 17, 12 times 12. Remember, this is your remainder. If that doesn't work out to be 0, it's kind of a checkpoint here. You've messed up something. Because the whole idea is that this is supposed to be a factor of this polynomial. Well, if it's a factor, it should go evenly and shouldn't get a remainder. So now we know that x plus 1 was this factor. It must have been multiplied by 6x squared plus 17x plus 12 to make that original polynomial because of what I just divided out here. Now then it says you always factor any further if possible. So if you start with a cubic and you do that division, you're going to get down here to squareds, which will then relate back to the factoring strategies that we reviewed in the opening video of our course. This is a hard trinomial. Let's see if it'll factor. 6 multiplied by 12 is 72. I want numbers that multiply to give 72 and add to give 17. Well, there are two numbers, they're 9 and 8. So this does factor. 6x plus 9, 6x plus 8. This one divides by 3 to give me 2x plus 3. And this one divides by 2 to give me 3x plus 4. And this one would just stay there. I'll just rewrite it. Now, the original question here is what we would call an expression. Notice it doesn't equal anything. What happens is students will treat it like it's an equation, and they'll get down here, whoops, and they'll try and tell me what x is equal to. All it asked for here are the factors. The factors means what expressions can you multiply together to give the original question. If you expand these three out, multiply these two, get the answer, multiply by this binomial, you will get the original. That process that I've just worked through is using the factor theorem to factor a polynomial. And that's what we want students to be able to do, factor polynomials. All right, so let's look at one where I just kind of go through that same process again and try and do it fairly smooth with less talking and me more kind of showing you what to do here. So, polynomial, none of our factoring strategies, look at the last number. So negative 6. I need some factor of 6, plus or minus, so it could be 1, 2, 3, or 6, plus or minus any of those. Let's suppose I try x equals 1. You don't have to, you can do this as quick as you can. So 1 I can do in my head. 1 cubed is 1 times 4, so I'm going to get 4. 16 times 1 squared is 1. Plus 19 times 1 minus 6. 19 and 4 is 23, minus 22. That one didn't work. Okay, let me try negative 1. Negative 1 cubed is negative 1 times 4 is negative 4. That's positive 1 times negative 16. That's minus 16. That's minus 19. Minus 6. Well, there's no way that's equal to 0. It's a bunch of negatives. So that's no good. Let's try 2. 2 cubed is 8. 8 times 4 is 32. 2 squared is 4. Times 16 is negative 64. 19 times 2 is 38. Minus 6. How do we make it out here? So I get 38. I get 70. And then a minus 60. This one works because I get 0 for the remainder. Therefore, I put 2 as my substitution. That means that x subtract 2 is a factor. Now, I'm going to figure out what is the other thing I would multiply x minus 2 by then to get this. So I'm going to do a synthetic division. So minus 2, x minus 2, divided into this. So 4, negative 16, 19, and negative 6. And we'll do the synthetic division on this. Bring down your 4, negative 8. Subtract, negative 8. Uh-oh, what's going on here? Oh yeah, 16, that's right. That'll give me 3. Negative 2 times 3 is negative 6. I have to get 0 here. So what this means, if I translate it back to variables now, and let's put it underneath where we got more room. We've got the factor x minus 2, which got multiplied by 4x squared. Take away 8x plus 3, and those two multiplied together would give me that expression. Then check the new factor that you just got, this one, and see if you can factor it with any of your other strategies that you have from grade 11 and grade 10. This is a hard trinomial, so I multiply 4 and 3, I get 12. Could I multiply to get 12 and add to get minus 8? Yes, I can. 4x take away 6. 4x subtract 2. This one divides by 2. 2x minus 3. This one also divides by 2. 2x subtract 1. And I have my x minus 2 that was already there. There's your 3 factors of that polynomial. Nice little stretch. So you are responsible to be able to work through this pattern. All right, here's another one. This is an easier one, at least to get your first factor, because 2 only has 2 factors, 1 and 2. Let's try w equals, can I do it by looking here? Let me see. Let's try 1. That would give me 2, take away 5, plus 1, plus 2. And what do I get for a remainder? 4 or 5. It works. Gives me 0. Remember, if you fill in a positive 1, your factor must have been w subtract 1. Do a synthetic division. Minus 1 divided into the original. 2, minus 5, 1, and 2. Bring down your 2, minus 2. Subtract, minus 3. 3, subtract, you get minus 2. Multiply, you get 2. Checkpoint, 0, which is what should happen. It goes evenly because it's a factor. Bring it back to variables. Now the variable this time is w, so it's w subtract 1, 2w squared, take away 3w, take away 2. Try and factor this. 2 times negative 2 is negative 4. Negative 3 is your middle term. I could use negative 4 and plus 1. 2w subtract 4, 2w plus 1. Divide this one by 2. W subtract 2, 2w plus 1. This factor translates down to here. There's your 3 factors this time. All right, we're rolling now. Find all the factors of this polynomial. I think this is the last one I've got for us. Oh, I got 2 more, I guess. All right, so I got to figure out something that'll make this equal to 0. Let's try. So it's only 2. It would have to be either plus or minus 1, plus or minus 2. It has to be a factor of the last digit. Let's try. Just looking at 1 real quick. 11 and 6 is 17. It's not going to work. Let's try negative 1. So negative 1 would give me negative 1 cubed is negative 1 times 6, so negative 6. That'll give me positive 1, so minus 17. That's not going to work. Minus 11, minus 2 doesn't work. 1 doesn't work either, so let's try 2. 2 cubed is 8 times 6 is 48. 2 squared is 4 times negative 17 is negative 68. 11 times 2 is a positive 22 and a minus 2. Did I do that right? 48, so that's going to be 70. That works. 70 and negative 70 gives me 0. All right, so that means that x take away 2 is a factor. Let's do a synthetic division to see what the other one that I'd multiply that by to make this. So 6, negative 17, 11, and minus 2. Bring your 6 down. Negative 2 times 6 is negative 12. Negative 17, subtract a negative, so that'll be negative 5. Positive 10, 1, minus 2. There's a good sign. I got 0. X take away 2. 6x squared take away 5x plus 1. Try and factor this, and again, a lot of times they're set up early on here to they will factor. These don't always factor. Sometimes you're done here, you can't go any further. So I don't want you to think that you can always factor this. It's just set up that way in the beginning to give us some practice. 6 times 1 is 6, and I want to get a minus 5, so again, it will factor. We'll use negative 3 and negative 2. 6x subtract 3. 6x subtract 2, that would multiply to give me 6, add to give me minus 5. This one divides by 3. 2x subtract 1, this one by 2. 3x minus 1, and I have my x minus 2 from before. There's your 3 factors. Now the last example I have here combines remainder theorem and factor theorem kind of together in one question. It says, given that x subtract 4 is a factor of this, So it's telling you a factor. Find the other factors after you figure out what the missing coefficient is. So let's figure out the missing coefficient first. Well, according to what I read here, if I substitute x equals 4, the remainder should be 0 because that's the only way something can be a factor of something. Well, let's do that to figure out k. So we're going to put 4 in for all the x's. And when I do that, it has to equal the remainder, which in this instant, because it's a factor of it, the remainder's got to be 0. 4 cubed is 64 times 3 is 192. 16 times k is a minus 16k. Subtract 24 plus 8 must equal 0. Negative 16k, let's see what I've got here. 192 and 8 is 200. So then 200 minus 24 is going to give me 176, which is going to take this to the other side and become a negative 176. Divide both sides by negative 16. And we'll see what I get here now for k. So k is going to have to be 1. So it's going to be 11. So that means that the original polynomial that I had the k value missing here, I now know that that polynomial was 3x cubed minus k, which is 11, x squared, take away 6x plus 8. What it wants us to do now is find the other factors once I now have k, which I do. So it wants me to factor this. Well, here's the good news. We don't need to do the trial and error because they gave us a factor in the beginning. I already know, right? We know that x take away 4 is a factor because it was given in the question. So that saves the trial and error step at least. We go right to the division step. So now we're going to take minus 4 and divide it into the original. So 3, negative 11, negative 7, and 8. Bring down your 3, take away 12, 1, negative 4, minus 2, 8, good sign, equaled 0 for the remainder. Bring the variables back in. So this is x subtract 4. This is 3x squared plus x minus 2. 3 times negative 2 is negative 6. And I want to get a plus 1 in the middle. So I would have to go with a positive 3 and a minus 2 as my hard trinomial factors. This divides by 3, giving me x plus 1, 3x subtract 2, and then I bring down my x subtract 4. And that is how I would combine the remainder theorem and the factor theorem kind of all in one question. So yes, we're getting into algebra that is pretty high level stuff. Unfortunately, or fortunately, that's where you need to be if you want to work in a pre-calculus and a calculus environment. You have to have solid factoring and algebra skills. So this section of the course does a great job in forcing us to dig at that part of our brain and get better at this. All right, so that's where we're going to stop for now. You have some practice questions to do, as always. If you have any questions, reach out. Best of luck, and as I said, if you get to the end of this, there will also be a formative assessment I'm going to get you to do on factoring polynomials and the remainder theorem. Thank you.